Hi friend, in this video we are going to discuss about the symmetrical fault calculation for any symmetrical fault. Normally any symmetrical fault happens with three-phase fault. In three-phase fault what happens that the fault magnitude remains same and they are apart with each other and all the phases are apart with each other with 120 degree. So normally in this video I plan this video to how to calculate this our fault current. Maybe it is the fault current or fault MVA. So in this video, first of all, for any network, first of all we need to draw a single line diagram. For this single line diagram, we need to convert in the reactance diagram. So for let us take an example so it will make the things clear. Let us suppose that we have one network where you can find, let us suppose this example that find the short circuit current that will flow into a complete three-phase short circuit at point F. Friend, we have three alternators here, A and B, having rated kV as 15,000 and 20,000, and their rated percentage reactance is 30% and 50%. What we will do, we have one point F here where the fault happens. So let us suppose this point F is our fault point, and this is our bus voltage as 12 kV. Now we will convert this single line diagram into the reactance diagram, but before converting this single line diagram into the reactance diagram we need to convert into the base kVA because these two alternators are not in the same kVA rating. So we need to consider a base kVA. We need to consider a base kVA where we can put A and B in the same platform. So let us suppose we have taken a base kVA as 35,000. Friend, here you can take any value. It's up to you what you want to take. Just for my easy calculation, I have taken 35,000 kVA. You may select as 60,000 kVA. 60,000 kVA will also make the calculation easier because it is the lowest common multiple of 15,000 and 20,000. So this is just 35,000. Now how we can calculate the percentage? Now we have already percentage reactance of alternator A, but it was on 15,000 kVA. Now on the base kVA we have to find the percentage reactance of alternator A. So on the base kVA the percentage reactance of alternator A will be, it's 35,000, that is our base kVA, divided by rated kVA into rated percentage reactance. Again I will repeat, this is for at base kVA the percentage reactance of alternator A will be the base kVA divided by rated kVA into the percentage reactance. So friend, it will come as 70%. Same for alternator B. Alternator B will be 35,000 divided by rated kVA, that will be 20%, and into rated percentage reactance, that will come as 87.5%. See friend, we have calculated both percentage reactance of alternator A and alternator B on base kVA. So I will highlight this percentage impedance on here reactance diagram. So in this reactance diagram now you can see that now A and B are on the same platform, and we have percentage reactance of XA came as 70% and XB as 87.5%. So this now this XA and XB are parallel with each other. So now see that the total percentage reactance we can calculate as this 70 into 87.5 divided by 70 plus 87.5, it will come as 38.89%. This is our total equivalent percentage reactance on our base kVA. Now the line current we have to calculate. The line current on the base kVA we have to calculate. It will come as 35,000 into divided by root 3 VL. Our VL is 12 into 10 to the power 3, so it will come as 1684 ampere. Now this 1684, we have the line current on base kVA and we have percentage reactance on the base kVA. So now the short circuit will come, the short circuit current will come as our line current into divided by percentage reactance. Since the line current came as 1684 ampere and the percentage reactance is 38.89, so it percentage means 38.89, on the top, on the numerator 100 will come. So on the equivalent we get 4330 ampere. So my friend, this is our fault current. This is our fault current when A and B are parallel with each other. So the fault current contributed by both A and B, it will come as 4330 ampere. Friend, I want to show you the another method for the same question. Now we have the full load current. Now we will find the separate full load current for alternator A and the alternator B. For alternator B we have given the kVA. The means the full load current delivered by A will be kVA divided by root 3 VL. So since the rated kVA is 15,000 into 10 to the power 3 divided by root 3 VL, it will come as 721.7 ampere. Now we have the percentage reactance. Percentage reactance of alternator A is 30%. So the short circuit current for alternator A will be 721.7 divided by 30%. It will come as 2405.5. Again, we will in the same manner we will calculate the full load current by B, and it will come as 962.28 ampere. And the short circuit again 962.28 divided by the rated percentage reactance of alternator B. It will be 50%. So now it is 19245 ampere. So the short circuit current contributed by alternator B will be 19245 ampere, and the short circuit contributed by alternator A was 2405.5. So we will summate both this ISC for A and ISC for B. Again we will get the 4330 ampere, which was the same which we had calculated earlier. Again friend, we will do one more question. This question is first of all I will read the question. We have three phase 20 MVA alternator having the rated voltage as 10 kV, and it has internal reactance as 5%, and it has given that how much we have to find the external reactance per phase to be connected in series with the alternator, so that the steady state current of the short circuit does not exceed 8 times the full load current. It means we have to find the apart from this internal reactance, we have to find the extra reactance that we need to connect in series with this alternator to restrict the short circuit current should not exceed the 8 times of the full load current. So let us solve this question. So this is the single line diagram we have. We have one alternator having a rated MVA as 20 and rated voltage as 10 kV, and the percentage reactance it has given 5%. This is the internal reactance of this alternator, and now we have to find this X, which we need to connect in series with this alternator to restrict the short circuit current 8 times of the full load current. Now we have for this particular MVA we have the full load current, that is, we know that it's MVA divided by root 3 VL. So this is 20 MVA divided by root 3 into 10 to the power 23. This one will come as the full load current. Now the percentage reactance required. See my friend, we have given the, suppose it's if we consider the normal full load current as 1 ampere, so we have to, for the maximum short circuit current for 8 times, we can calculate the percentage reactance. Now what is it will be? It will be full load current divided by short circuit current into 100. So let us consider it was 1, full load current was 1, and we need to restrict the short circuit with 8. So divide the 1 by 8 into 100, it will come as 12.5%. So the external percentage impedance we need to find out at 7.5%, because 5.5% was already our internal impedance, and this was our total impedance. So the external impedance we need to the external percentage impedance came as 7.5%. Again this 7.5% will be equal to Ix by V into 100. So it will come as 1154.7, because this is our line current, this is our full load current, that is 1154.7 ampere, and we need to find this X divided by this phase. Here we have to find the per phase to be connected in series. So for the per phase voltage is 10 by root 3 into 100, so the X will come as 0.375 ohm. Let us do one more question. In this we have to find the fault MVA for this network. We have 4 alternator here and 1 bus reactor. So this for this alternator A, B, C and D, and let us suppose this bus reactor named as E. This alternator has base kVA is 10,000, this C is 8,000, D is having 8,000, and for E we have 5,000, and the rated percentage reactance is 10%, 12%, and this bus reactor has 10%. Again, for this same question we need to repeat the same procedure. What we have to do first, First of all, we need to find the base kVA. Let us suppose the base kVA is 10,000. You can, again, I have to say that you can take any value. You can take any value for this base kVA. I took here 10,000. You may take as 20,000. You may take as 30,000. It's only up to you. So consider the base kVA I have considered here as 10,000. So again, with the same procedure, I have to find the percentage reactance for this A, B, C and D on the base kVA. Since the base kVA and the rated kVA is same here, so the percentage reactance of A and B will come as 10%, and for C and D it will come as again 10,000 divided by rated kVA into the rated percentage impedance. It will come as 15%. For the bus reactor, again for the base kVA divided by rated kVA into 10% as a rated percentage reactance, it will come as 20%. Now we will draw the equivalent diagram, that is called as the reactance diagram for this single line diagram. We will come here and we will see that for A and B it is 10%, 10%. For C and D is 15% and it is 20%. Again we will simplify this reactance diagram and see this 10%, 10% are in parallel with each other, so it will become half, will come as 5%. This is 20%, and again this 15% and 15% is in parallel with each other, so it will come as 7.5%. Now we have fault here. Means this 5% and 20% will be in series, so this will come as to 20 plus 5 and it will be in parallel with 7.5%. so the equivalent percentage reactance will come as 5.77%. And again this fault kVA, how we can calculate the fault kVA? We have the base kVA as 10,000 divided by the percentage reactance. So the base kVA divided by percentage reactance will give our fault kVA. So what is our base kVA? We took as 10,000, and the one who has took 20,000 they can put here 20,000, and the one who has took 30,000 they can put here as 30,000. But in my case I took 10,000, so I'll put here 10,000 divided by the percentage reactance, which came as 5.77%. 5.77%. So this came as 173,310 kVA. We can simplify in the MVA and it will get we will get 173.310 MVA. So friend, if you have any doubt regarding this kVA, or if you have any more question about symmetrical fault, you are free to ask any question. You can tell me how you like this video in the comment box. Thank you.